Okay. So guys, let's start with the post-contest discussion of Goodbye 2023 round. So it also happens to be the last round of 2023. So we'll go one by one. We'll go A, B, C, and then D. So let's start with uh, A. So the first problem is just like in a in a sequence A, the product of those numbers was 2023. The number K was removed, and then there were K numbers removed, and then we were left with a sequence B of length n. Okay, we are given B, and we have to find the K elements that were removed from it. Okay, so the basic observation here is that first there was a particular array. Let's say the elements are A, B, C, D, E. There are at most 5 elements. The product of these is 2023. If some elements are removed from this, okay, let's say these 3 elements are removed from this, still, okay, these elements are removed from this, and then whatever is left is this much. The thing to notice is that if this entire thing multiplies to 2023, then this thing will be a factor of 2023, right? Because if everything multiplies to 2023, a subset of these numbers, the product of a subset of these numbers will be a factor of 2023. Is this much clear? Is there any doubt in this much? Okay, it is clear, right? Now, if we are given this, what do we have to check? First, we have the number 2023. Let's say we get the first element, let's say A. First, we need to check if this is a factor of 2000, whatever number we have right now or not. If it is a factor, I will just divide this with this particular number. Then I will move on to B. Basically, what I want to do is I want to find the number 2023 divided by A into B. I am doing it one at a time. So first I'm dividing A, then I'm dividing B. So first I'm checking that whatever numerator I have, is it divisible by A? If it is divisible by A, then I am dividing it by A. Okay. After that, I'm checking it for B, so on and so forth. If any number is not divisible by 2023 or the number which is left, I can say that, okay, uh, this is not a valid solution because each number is a factor of 2023. So it should be divisible by that number. So if it is not, I just say that, okay, this is not possible and I print -1. Otherwise, what I do is I keep dividing. And in the end, let's say I have a number X, right? So whatever, like, let's say it was ABC. So I divide 2023 by A into B into C. And in the end, I am left with a number X. Let's say we had to print K numbers. I can just print X and then I can print 1 K minus 1 times. Because X into 1 will still be X. And whatever numbers we had into X will give us 2023. Is this much clear, guys? Is there any doubt in this? Clear? So let's look at the solution. So the solution for this is very simple. I am taking in the number of integers that I'm getting. I'm taking in how many integers we need to print. I'm having two variables, possible is equal to 1 and whatever is remaining. So possible basically stores if it is possible or not possible. Each number has to be divisible by whatever is remaining. So that is why possible is equal to possible and remaining modulo X is equal to 0. And after that, I'm just dividing the remaining number by whatever I get as input. In the end, if it is possible, that means that each and every number was divisible by rem, and then we divided by X, right? So if it is possible, I print yes, then I print the remainder, and then for the remaining K minus 1 times, I print 1. Otherwise, if it is not possible, I print no. Is the code clear as well? Is there any doubt in the code? Clear. So let's move on to problem B. Problem B is a very interesting problem that, like, if you think about it, then there's a very simple solution that we can find to this. Let's read and try to understand. A certain number x is chosen, okay? And you are given two integers a and b, which are the two largest divisors of the number x. At the same time, the condition 1 smaller than equal to a, smaller than b, smaller than x is satisfied. Now we are asked that we have to find this particular x. So what does the problem statement say? The problem statement says that we are given two numbers a and b, and it is guaranteed that b is the largest divisor of x and a is the second largest divisor of x. Okay, and what are we told? We have told that we have to find this particular x, and of course it is given that a smaller than b smaller than x, right? This holds, right? This is what is given in the problem statement. Just find LCM and multiple. Let's discuss the solution. So how do we get the intuition of this problem? We know that b is the largest factor of x, right? X. And any number x, right? It can be, so this is for people who didn't know, okay? This is a very nice example. Any number x can be shown as a product of primes. For example, the number 9, it can be shown as product of two primes, 3 into 3, right? For example, there is 12. 12 can be shown as a product of 2 into 2 into 3, like this. So x can be shown as a product of many primes, right? P3, so on and so forth. It is not necessary that they are same, but it can be said that x can be shown as a product of some primes. Now let P1 be the smallest prime in x, okay? And let P2 be the second smallest prime in x. Is this much clear, guys? Is this much clear? Like a number can be represented as a product of primes, and let P1 be the smallest prime in x, and let P2 be the second smallest prime in x. Is this much clear? Okay. Now, if this much is clear, can I say that B is nothing but x divided by the smallest prime? We have to remove something, no? So what will we remove from x? We will remove the smallest prime from x. Then we will get B. Isn't this true? Is this much clear, guys? Let me just take this the other screen. Yeah. Is this much clear, guys? Okay. Now, talking about A, this is the largest factor. Okay. This is the largest factor. Now talking about the second largest factor. Now, for the second largest factor in x, there are two choices. Like if the smallest factor occurs twice, we can say that x is either x into p1 into p1, or x is a is x divided by p2, where p2 is the second smallest prime in x. Okay. Why does this hold? Okay, for example, let x be p1 into p1 into p2 into p3, so on and something. Let's say p1 is 2 and 3 and 5 and something like this. Here you can see that if this is x, the largest factor is nothing but x divided by 2. And for a, which is the second largest factor, we have two options, right? Either it is the whatever is largest amount, x divided by 4, or x divided by 3. Now, why do I say that x divided by p1 into p1 is a possibility? Now think about this possible case where x is 2 into 2 into 5. Okay. The largest factor here is x divided by 2, which is 20 divided by 2, which is 10. And the second largest factor, is it x divided by 5 or is it x divided by 4? What is it, guys? What is it, guys? It's x divided by 4, right? So it is 20 divided by 4, which is 5. Now tell me, could the second largest factor, could it have been x divided by 2 into 5 or x divided by 5 into 2 into 2? Could it have been this? It can't be this, right? It has to be either x divided by p1 into p1, where p1 is the smallest prime in x, or it has to be x divided by p2, where p2 is the second smallest prime in x. Is this much clear, guys? A can be one of these two. Okay. And B has to be x divided by p1. This is for sure. Okay. Great. Yeah, if x does not occur twice, it will just be x divided by p2. So of course, 2 times p1 has to exist, or 1 time p2 has to exist. Only then it will be possible. But if there are 2 times the smallest prime and there is the second smallest, then it will be that. Now let's just solve for these two cases. Okay, let b be equal to x divided by p1 and let a be equal to x divided by p1 into p1. Right? So now what do we have to find? We just have to find this p1, because if we find this p1, we can say that p1 into b is equal to x. Isn't this true? Right? So how will we find this p1, guys? We are given a, we are given b, and we have to find p1.
P by A.
Exactly. So if we do b divided by a, where b is nothing but x divided by p1 and a is x divided by p1 into p1, these two cancel out, these two cancel out. What we are left with 1 by 1 upon p1, which is nothing but p1. So b by a gives us p1, and in the end we will just print b into p1. Now we solved for one case, okay, where b is x divided by p1 and a is x divided by p1 into p1. Now what if b is equal to x divided by p1 and a is equal to x divided by p2? Okay. Now what will, now again, p1 into x is equal to b. Now we have to find this particular P1. How do we find this P1? Can we find this P1? How do we find this P1 now? Tell me, guys. And we know for a fact that this contains P2 and this contains P1. Okay. We know this much. How can we make use of this fact? Yeah. So if x divided by P1 is A and x divided by P2 is x divided by P2 is A and x divided by P1 is B, we need to find x, right? As someone correctly mentioned in the chat, what is x? Isn't x nothing but the LCM of P comma A? Is, isn't this true? Tell me, guys. Okay. Now you, like someone correctly asked, why does this hold true? Okay. So what is x? X is P1 into P2 into, let's say, P3 into P4. Okay. And A is uh, x divided by P1, x divided by P2, which is P1 into P3 into P4, and so on. And B is nothing but x divided by P1. So P1 gets removed. So P2 into P3 into P4, so on and so forth. So can't you see that this is just missing P2 and this is just missing P1? So the LCM of these two numbers is nothing but x. Like if I multiply this by P2 and if I multiply this by P1, this is x, and this happens to be the smallest number that is a multiple of both A and B. Is this much clear, guys? P1 is also a prime, P2 is also a prime. So LCM of A comma B is just x. Does it make sense? Is it clear? Are there any doubts in this? It is clear, right? Great. So to sum up what is B, if now we solved for these two cases, okay? Now how do we know which case is which? In this particular case, we knew that we had to do B divided by A. Now, when can we do B divided by A? We can only do B divided by A when B modulo A is equal to 0, right? So if B modulo A is equal to 0, we take the first approach. And what is the first approach? We just print B into P1, where P1 is nothing but B divided by A. And otherwise, if this is not true, we just print LCM of B comma A. Is this much clear, guys? Right? So moving on to the implementation of this.
Can you
So
explain once in just brief?
yeah, so sure. So what didn't you understand?
Like, like it takes so much time to solve it. I eventually solve it, but how you can think within just 2 lines code? This is what I am asking.
So so how do you go about thinking this? Right. So the basic things that you can consider is, if I am given a number x, b is nothing but x divided by the smallest prime. This is for sure. B is, of course, this. Now for A, there are two conditions. Like if you think greedily, A can either be X divided by the second smallest prime, and the other part, like otherwise, if there are two occurrences of P1, it can be X into P1 into P1. These are the two cases for A. Now you just solve for both these cases and you will come up with a solution. I did think the entire approach during the contest, yes. So this requires a bit of, you could say, number theory. Like if you knew that each number can be represented as primes, you could have gone about thinking this way. I hope this answers your doubt.
Okay.
And now it's just the code. If B modulo A is equal to 0, we go by the first approach and we print B into B divided by A. Otherwise, we just have to print LCM of A comma B, which is exactly what we do. If you guys didn't know the formula of LCM A comma B, it is just A into B divided by GCD of A comma B. This is the formula for LCM of two numbers. I hope this much is clear. Is B clear to everyone? Okay, so if B is clear to everyone, let's move on to problem C. So what does problem C say? Masha and Olia have an important so on and so forth. You are given an array of size n. Masha goes first and the player takes turns. Each move is described by following sequence of actions. If the array of size 1, if the size of the array is 1, the game ends. The player who is currently playing chooses two different indices I, j and performs the operation, removes AI and AJ from the array and adds a number AI plus AJ by 2 floor division into 2, right? In other words, first divides the sum of the numbers AI, AJ by 2 rounding down and then multiplies it by 2, right? Masha aims to maximize the final number while Olia aims to minimize it. So for every prefix, we have to solve it. The thing is, if we can solve it for an array, then we can easily go about solving it for each prefix. Okay. Let's first go about thinking how we will solve it for one array, and then let's solve it for each and every prefix because it doesn't really matter much. So if we are given an array, okay, before moving on to that, let's think of the conditions of this, right? We are given two numbers x and y, and we first floor divided by 2 and then multiply it by 2. So let's take some cases and analyze what is happening. Let's say x is odd and y is odd. Okay. So what is the smallest odd number? It is 1, right? So 1 plus 1 gives us 2. Okay. Now what will happen if I do this? It will be 1 plus 1 divided by 2 into 2. So 2 divided by 2 is 1, into 2 is 2. So you can see that the sum remains intact. Now let's see what happens when x is even and y is even. Okay. If x is even and y is even, then let's take 2. Okay. These two are 2. These are the smallest even numbers. So x is 2, y is 2, x plus y is 4. Okay. 2 plus 2 divided by 2 into 2. So 2 plus 2 is 4, divided by 2 is 4, 2 into 2 is 4. So here also the sum remains intact. Now let's take the last case where one of the numbers is odd and one of the numbers is even. Does the sum reduce here? X is 1, y is 2. The sum is 3. 1 plus 2 divided by 2 into 2. Here you can see, guys, that 1 plus 2 is 3. 3 divided by 2 is 1. And 1 into 2 is 2. So you can see that here, when one of the numbers is odd and another number is even, the sum reduces by 1. So it was not for odd, it was not for odd even, it was even, it was for when one of the numbers is odd and one of the numbers is even. So for the first person, okay, what was the name of the first person? For Masha, what is her strategy? Her strategy is nothing but she has to minimize this odd even moves. Okay, she has to not allow Olia to do a lot of these odd even moves, because if she doesn't allow the other person to do a lot of odd even moves, her sum increases by itself. Isn't it true? Like before that, I wanted to ask you guys, you for you all the problem statement is clear, right? You guys understood what the problem statement asks, right? Okay. Now is this much clear? Like for Masha, her job is that she has to minimize this odd even type of moves. Okay. Now, one more thing to consider. Whenever I do a odd move, okay, I take two odd elements and I do a move on this. Because of the nature of this function, okay, this is x plus y divided by 2 into 2. Because this 2 is there, the number which I get, it is always even. Does this make sense, guys? Like whatever number I put inside this function, whatever I will get out will always be even because of this into 2, right? Okay. So tell me one thing, guys. How can Masha reduce the number of odd even moves? How will she reduce this? By picking two odd numbers. Exactly. Great. So if you keep picking two odd numbers, what will Masha do? Let's say there are x odd numbers and y even numbers. So she will pick two odd numbers and this will create an even number. Then what will the other person, what will Olia do? An even number, an even already exists. It has to exist. Okay. Because she is going second. It will exist. So she will take an odd, she will club it with an even, and then it reduces by 1. What if we take two even numbers? See, if you take two even numbers, you are creating an even number, but you are not reducing the number of odd numbers. No. So in the next move, Olia can just pick a odd number and a even number, and then my sum will reduce by 1. Does it make sense? Like clubbing two even numbers will make me an even number. It doesn't affect the odd numbers at all. But having two odd numbers will reduce the number of odd numbers, and then it will increase the number of even numbers. So if there are no odd numbers in the end, then there will be no -1 operations. Right? So what is Masha's approach? Her approach is take odd numbers and keep clubbing them. And for Olia, it is take odd even numbers and keep clubbing them. Okay. Now there are let's say there are four odd numbers. Okay. And let's say there are zero even numbers. Okay. For now. Now, first Olia will take two odd numbers let's say all of them are 1 currently. Okay, 1, 1, 1, 1. This is the array. So Olia will take these two numbers and this will become 2, right? So it will go here. Now this then Olia will take one odd number, one even number. Then she will merge these two. So this will again become 2, the sum reduced by 1. Keep this in mind. And now there is one odd left and one even left. So we are forced to reduce the sum. Can you notice this, guys? There was one odd left and one even left. So now we are forced to take this and it reduced by 1 again. So in the end, our sum was 2. Basically, our initial sum was 4 and it reduced by 1 once and reduced by 1 twice. But okay, we were forced to take it for 4. Are we forced to take it for 5? Let's say there were 5 odd numbers. Okay, 1, 1, 1, 1, 1. So we initially take these two numbers, form an even number. Then Olia will take this, and then make the even number, which is 2 again. So these get erased. And in the end, we take these two numbers and we make it into a 2. So when we had 5 odd numbers, were we forced in the end to make an odd number? Tell me, guys, were we forced to make the odd number? No, right? When we had 5 odd numbers. So let me illustrate this. I think it will make it more clear. If I have some amount of odd numbers, I take 2 odd numbers and I make an even number. Okay. So I am never getting depleted of even numbers. Okay. Then Olia will take an odd number. Then she will combine these two even numbers, and then she will form an even number. So can you say that for every 3 odd numbers, I reduce my sum by 1? Is this much clear? Like for every 3 odd numbers, I will take 2, I will make it into an even number. Then Olia will come, she will take whatever odd number she wants. It doesn't really matter because the sum will only reduce by 1. And then she will club it with the even number we have made. And then she will make it into an even number. And in this particular operation, our sum reduces by 1. So then this process will repeat. We will again take 2 odd numbers. We will club it into an even number. Then Olia will take an odd number. She will club it and make it into an even number. But then our answer will again reduce by -1. Is this observation clear? That for every 3 odd numbers, our answer reduces by -1? Yes? Tell me, guys. Is this clear for everyone? Are you guys having doubts? Okay. Okay. So first thing I want to ask you is this odd even type of operation. If I take one odd number, one even number, and I do what is asked, it will reduce my sum by 1. Is this much clear? Okay, this much is clear. Now, we start with some amount of odd numbers. Okay. We also discussed that for Masha, the most optimal strategy is keep taking 2 odd numbers and keep clubbing them into making an even number because that does not reduce the sum. But it reduces the number of odd numbers, which is great. So it will bar Olia from making these odd even type of move. Is this much clear? Yes. Okay. Now, so if we have to do these 2 odd number moves, and after this, Olia will do an odd even move. So what does this show? Like we take 2 odd numbers We club it, make it into an even number. Then Olia takes one odd number, and since this, we club this to make an even number, right? So it doesn't really matter if we have evens or not. But Olia will take this odd number, she will club it with this even number, and in this process, we subtract 1. So for every 3 odd numbers, we subtract 1 from the sum of whatever our array is. Exactly. An odd triplet, every odd triplet leads to an odd even pair. So for the next 3, so on and so forth. Yes, this means that whenever Olia will find a free odd, the sum will reduce by 1. So if there are X number of odds, can we say that the sum reduces by X by 3?
But suppose x is not completely divisible by 3, then
Yes, we will take that case as well. But for now, can we say that X for sure reduces by X by 3? The sum reduces by X by 3. Okay. Now, here I also showed you a case, okay, where we are forced, when there were 4 odd numbers, we are forced to merge this, right? So what does this mean? Let's see. Let's say that there is one odd number, okay? Here the sum does not reduce. Let's say there are 3 odd numbers. The sum reduces by 1 because of this. And after this, there are no odd numbers left. It is divisible by 3. But let's take the case for 4 and 5, okay? For 4 odd numbers, we know that it is X. We know that there are 4 odd numbers, right? So 1, 2, 3, 4. So these two we club, we make an even number. Then Olia clubs this and makes this into an even number, and then it is our chance. And since these two are the only elements left, aren't we forced to do this operation, guys? Aren't we forced to do this operation? We first took these two, then Olia took this, and now we are forced to take this odd number and do an odd even operation, and the sum reduced by 2. So what can we say? When the number of odds modulo 3 is 1, okay, this will similarly repeat for 7 and so on and so forth. When x modulo 3 is 1, then we will subtract an extra digit, extra number, because we are getting forced. But what about x modulo 3 is equal to 2? When x modulo 3 is equal to 2, for example, there are 5 odds, okay? These two we club, we make it into an even. These two Olia clubs, there is -1. We form an even. Now these two, okay, these two we club and we make it into an even, and then these two Olia clubs, and then there is no negative. So only when x modulo 3 is equal to 1, we are forced to do that extra -1 operation. So what did we understand? We understood that for if there are x odd numbers, the sum will reduce by x by 3. And if x modulo 3 is equal to 1, then the sum will reduce by an extra 1. Is this much clear, guys? Yes or no, guys? Tell me. Okay. So now the question asks that we have to solve it for every prefix. So we just iterate from 0 to n minus 1. We keep the count of how many odds are there for each particular prefix. Okay. And then we just have to take care of this. Let's look at the code and try to understand now.
I had
So,
solved 1 second.
yeah.
I have solved this question in a very lengthy way. I have मतलब मैंने डीपी लगा दिया था, मतलब मैंने एक डीपी मासा के लिए बना दिया था, एक मैंने डीपी उसके लिए बना दिया था, फिर मैं उससे किया था.
Okay.
So मैं ये पूछना चाह रहा हूँ कि हाउ वी शुड डेवलप सच नो मैथमेटिकल बेस्ड फॉर्मूला. लाइक ये मेरे दिमाग में नहीं आता कि हर एक 3 दिन से देख ले, मैं डीपी सोचने लगा हूँ.
So this is kind of a greedy strategy. Like first you think like I don't know how you solved it using DP, but here you can see that for every odd and even, like if you understand how that function works, when you take one odd one, when you take an even, that is when it reduces by one. So our goal is to reduce the number of such operations, and Olia wants to do as many operations as we want. So that is when we come up with, we take two odds and then the other person takes up one odd, one even. And another observation to make is that every whatever two numbers you put in, the number that comes out is always even. So these
What
so once you
what I was doing, I have made two arrays for Masa and for another person. So दोनों के लिए 0 0 एज केस हो गया है कि अगर 0 0 रहा तो 0 0, 1 1 रहा तो 1 1. फिर 2 पे मैंने ऐसे किया कि अगर मासा का है तो फिर 0 प्लस फिर अनदर का -2 किया था. जितने ऑड नंबर आएंगे ऑड -2 अनदर लेके, और फिर अनदर के लिए 1 प्लस इवन ऑड -1 किया था. This
okay,
is how I was thinking.
do share your solution to me on Discord. I'll definitely look at it. Seems interesting. Uh,
Where I can share you?
on Discord, I'll just ping you. Just give me like 1 second. Let me just explain D as well. Then just
Okay.
tell you. Right. So this is all that we had to do. Right. We just need to know how many odds are there. So first you take in the array, and after that you just iterate through every prefix. The sum, you just do sum plus equal to AI, stating that the sum of all elements is right now AI. Then what we discussed, you just, if I is equal to 0, that if you're on the first element, it doesn't really change. So you print out sum. Otherwise, you print sum minus odd divided by 3 and minus odd modulo 3 is equal to 1. What this particular line of code does is, if odd modulo 3 is equal to 1, it returns a 1. Otherwise, it returns a -1. It returns a 0. It's just like a if block, right? It will return true if this is true, and then -1, extra -1 will be subtracted. Otherwise, there will be nothing that will happen. So this was more or less about C. Is there any doubt in C, guys? Were you able to, for people who are not able to think about C, how did you think of the x modulo 3 is equal to 1 idea? You just solve it for each modulo 3. Like you think for when x modulo 3 is 0, x modulo 3 is 2, x modulo 3 is 1. And you notice this pattern. Is the solution clear, guys? Great. I will get back to how to solve it. Tell me, what were you not able to understand? The last L statement. So here we discussed, right, that for if there are x odd elements, then x by 3 will get reduced. And then if x modulo 3 is equal to 1, then we have to subtract another -1. So this is just what I do in one line. It is not necessary that you have to do in one line only. This is just how I have implemented. Like you could do it in 2 lines. Like, yeah, there is no need to calculate even. So you could do it in 2 lines. If odd modulo 3 is equal to 1, print sum minus odd modulo 3, so on and so forth. Yeah. So moving on to problem D. So problem D is actually like this involves a strategy. Okay, like coming up with such a solution, you might either be a math genius and you will solve it. Otherwise, what you could do is you could write a brute force and then you could observe. Now, the thing, what does this question ask? This question says that you are given an odd number n. It is very important that this is odd. You could solve it for even separately, but only odd. It does matter. Okay. You need to find n different numbers that are squares. Okay. But you have to also make sure that the length of the number is also n. Okay. Don't do it, Tanish. Right. This is being recorded, so it will go off to YouTube. Right. So the thing to notice here is that this much information is all that you needed to solve this problem. But what is the strategy that I used? Okay. First of all, to come up with something by your own in this problem, like you 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 don't notice anything, you prove something, and then you come up with the solution. It's very hard, because how do you come up with n numbers such that their length is n, and so on and so forth, right? So how do you go about solving this problem? So in such problems, your approach should be to write a brute force. Okay. You could do this mathematically as well. I'll tell you the mathematical solution in a bit, but I'm just sharing a general strategy that you could do. Right? For every length, print, what do you need to print? Print all the squares of that length. Length. Okay. If you write this much brute force, you will see a pattern. And now I will tell you what that pattern is mathematically. Okay. Tell me, guys, what is 13 square? Tell me, what is 13 square? Okay. 169. Now tell me, what is 103 square? Put this in the calculator and tell me what is 103 square. It is 10609. Similarly, what is 1003 square? It is 1006009. And what is 10003 square? It is 100060009. Right? Now, another thing I want to ask you is, what is 31 square? 31 square is 961. What is 301 square? 301 square is, yes, it is 90601. What is 3001 square? It is 9006001. Okay. Now you can see that you can see these patterns. Okay. Now, apart from this, what else what else mathematical observation you need? If x is a number, okay, x is a square and y is a square. If you multiply these two numbers, this z, this will also be a square number. This is the main observation that you want. Why? Because if each prime is there even times in this and each prime is there even times in this, then each prime will be there even times in this as well. This is the main observation. If you take two square numbers and you multiply them, it will give you a square number. Does it make sense, guys? Tell me, guys, does it make sense? If you take two,
How? Please once explain.
yeah, sure. Okay, so maybe this is not so intuitive. Let's say x is a square number. So what is a square number? Okay, I'll define this square number in a different way. Maybe you didn't know this till now. If a number is a square, Okay. Every prime minute in it occurs even number of times. Why does this statement exist? I'll prove it in a very simple way. A prime s can be said as x into x, and if there are some primes in this, there are same number of primes in this, so the count becomes double, right, of the primes. So if there were a amount of 2's in x, there will be 2a amount of 2's in s. Hence, each prime occurs even number of times. And this is how squares can be defined. Like if each prime occurs even number of times, you can say that the number is a square number. Does this make sense? Let's say this is 2 into 2 into something. Let's say this is 3 into 3. No, this is also 2 into 2. This is x into x, right? So this occurs twice, this occurs twice. So in s, it will be 4 times. Now, the thing to notice is that why do I say x into y will be, if this is a square number and this is a square number, why will this be also a square number? So first of all, here each prime occurs even number of times. Here also each prime occurs even number of times. So when I multiply these, in this number also, do you guys agree that each prime will occur even number of times? Let's say x is 2 into 2 into 3 into 3 and y is 7 into 7. So if I multiply this, don't you guys agree that in my new number that I get, everything will occur even number of times? And now going back to our definition, if a number is a square, every prime in it occurs even number of times. Hence, since every prime occurs even number of times, this z that we formed is also a square number. Is this much clear? I proved it for you that if you have two squares and you multiply it, the resultant is also a square. Okay. So 169 is a square. If I multiply this by 100, 100 is 10 square. Okay. So 16900 will also be a square. Similarly, 1690000 will also be a square because I'm multiplying this by 100. Similarly, 169000000 will also be a square. Does this make sense, guys? It was just specific to this problem. It doesn't really matter. Like for this particular problem I'm having, like it makes sense that I keep 0, 0. There might be many solutions. For my solution, doing 100 is optimal. Okay. So what did we notice? For n is equal to 3, what are the numbers? 169, 196, and 961. Okay. So if n is equal to 5, how do I extend
Can you
this?
can you explain me once again the concept of 100? What you have noticed there?
If once, so I said that if we multiply two squares, the resultant is a square. So 169 is a square and 100 is also a square. If I multiply these two, 16900 is also going to be a square number. Similarly, if I multiply this by 100 again, this is a square number and this is also a square number. This will also be a square number. So 169 and any number of even number of zeros will be a square, right? Yeah. So now for n is equal to 5, how do we make a solution using only these three numbers? So 169 is a square. I will just add two numbers, two zeros after it. Okay. 196 is a square. I'll just add two zeros after it. And 961 is a square. I'll just add two zeros after it. Okay. Now, if I wanted Now, here, before all of this, before discussing all of this, we know that 1609 is a square and we know that 90601 is a square. Basically, if I want to increase its length by 2, it was 3. If I want to increase it by 2, I just add 0 between 1 and 6 and 6 and 9. So here 10609 is a square and 90601 is a square. We found 5 numbers. Similarly, let's say from 5, we wanted it for n is equal to 7. What do? We do 1690000, 1960000. These all numbers, okay? 9610000, 16010609000 and 9060100. And in the end, what do we add? We just add 1006009 and 9006001. That is all that we need to do. And then we can print the answer. Is this much clear, guys? Like if we have the answer for n minus 2, for n, what do? You take the previous answers, you just add 2 zeros to all of it, and then these are the extra 2 numbers that you have to add. And these 2 are squares we just proved in the start. And how to come about these numbers, I just explained using this mathematical formula that if you have 2 square numbers, if you multiply them, you will get a square number. Is this much clear, guys? So we just need a way to print these numbers. How do we go about printing these numbers? You can apply a lot of ways to print these numbers. But my basic observation was that first, there is no gap between 169. Then there is a gap of 1 zeros between 169. Then there is a gap of 2 zeros between 169. And similarly for 961. But this does not occur for 196. So I just have to print 169, 10609, 100609. Similarly for 961, 90601, 900601, and then just 196 with the remaining number of zeros. So that is more or less about this solution as well. First, I print 196 plus the number of zeros, and then this is just the distance between 1 and 6 and 6 and 9. So initially the distance is 0. So I print 169. Then I print 10609. And then whatever remaining zeros are there, I print that many zeros. So I just check that how many numbers I need. I need count number of numbers. If count is greater than 0, I subtract count. And then I print this number. Then again, I check if count is greater than 0, I do count minus minus, and then I print the 961 variant of the same thing. Is this much clear, guys? Is this solution clear? Are there any doubts? And of course, n is equal to 1 case is the only edge case that we need to take care of because we can't make 196 and 169 out of this. So that was more or less it for this post-contest discussion. I hope you guys were able to understand the solutions. If you have any doubts, feel free to ask me after this post-contest discussion. I'll just stop recording and let's have an informal chat, right? Let me just stop recording.